We talked about product rule last time, and the idea of product rule is that if I'm multiplying two different functions, so if we say f of x times g of x, this is the idea of multiplying two things. And if I take the derivative using the symbol d over dx, that's a fancy way for us to say take the derivative of f of x with respect to x. Okay, we had our rule, take the derivative of the front, leave the back alone, plus the derivative of the back, leave the front alone. Okay? And we demonstrated that this could also work with a constant. That if I took the derivative of a constant, this would have been 0, because the derivative f prime of a constant is 0, leave the back alone, plus f prime of x, leave the front alone. Okay, just rewriting with f of x. And we realize that, hey, 0 times anything goes away, and we're left with our previous definition of k f prime, meaning just take the derivative of the function and you can leave the constant alone. There's a couple of rules that we talked about before. Now, what they're going to have for you do in IXL looks quite terrible, but it is no different than what we've been doing already. So let's go ahead and look at our example in IXL, and let's read it. The function f and g are both differentiable. That means we can take the derivative. We mentioned that before in our definition. The function h of x is defined by h of x is just us saying g of x times f of x. They just reverse it, not a big deal. These are just letters. Now, they give us a bunch of conditions that if f plug in 1 is 8, f's derivative at 1 is 6, g at 1 is 2, and g's derivative at 1 is negative 2, what is h prime of 1? Okay, so people get confused sometimes by this, but I want to rewrite this as, hey, what is just h prime of x? So we said h up here was just the product rule. So let's write it out. Once we write it out, we can skip a couple of steps later, but this is going to be g prime f plus f prime g. Okay, take a look at the pattern. I just stuck with what they gave me. Take a derivative of the front, leave the back alone, plus the derivative of the back, leave the front alone. Now, what's the difference between x and 1? Nothing, except me just writing 1 every time I see x. So one thing you need to realize is that you do not plug in the 1 till you take the derivative. You do not plug in the 1 till after we take the derivative. That's a big thing here. Some people will plug it in and they'll get a constant, and then they'll take the derivative of the constant and they'll be 0. That is not true. We always have to take the derivative first before we plug it in. Because the statement is actually saying, what is the derivative at 1? What is the derivative at 1? So fine, take the derivative first, and then we're going to plug in 1. Now, they give us all the values that we need. G prime, that's negative 2. F of 1 is 8, plus f prime at 1 is 6, and g prime at 1 is 2. The answer is negative 16 plus 12 gives us negative 4. That was crazy. It seems like it's a lot of writing. And know what? It's really just a puzzle that we're figuring out. We take the derivative of that separately, and only after we've done the derivative do we plug in that value 1. Okay, let's plug in negative 4. Cross our fingers. Yeah. Now, to do this a little faster, we can just plug in the value, in this case, looking here. So you guys can see this. H prime at 5. Okay, what is H? H is our product rule. So let's just write the product rule with 5 in there. H prime of 5 is take the derivative of the front, which is f and g, right? F prime of 5, leave g alone, plus g prime of 5, leave f alone. We can go back and look at the values that they give us. Just plug it in. So not supposed to be super hard, but it is kind of confusing when you see all this stuff going on. But once I write it out, I'm just going back to the problem to copy the numbers. -1, 8, so that's plus 1 and 4. Okay. So in this problem, they didn't have me actively take the derivative. They gave me all the answers. They gave me all the constant values. -8 plus 4 is -4 again. Okay, so your homework today, the IXL for K2 and K3 for product and quotient isn't that high. Okay? I think maybe I put like 50.
Thank you.
Yeah, so it's really short, but it's not always ice cream and fun. Let's go back. Let's take a look at the quotient one. Quotient one is a little more messy. Okay. So just like before, they gave us all the plug-in values. They gave us all the plug-in values. The problem is we have to set this up correctly so we don't mess up. So let's go ahead and use the letters that they gave us. Is G on top and F on bottom. So H prime of X is, let me actually write this first. H of X is G of X over F of X. Okay, just the letters have been swapped, it's okay. But whenever I state the rule, I don't use letters, I use position. Derivative of the top, leave the bottom alone, minus derivative of the bottom, leave the top alone, all over the bottom squared. Write this a different way. Okay, hopefully you guys were able to do that yesterday in the worksheet. I saw a wide variety of scores when I was reviewing it. A lot of you guys got number 24 wrong. Yeah, a lot of you guys got number 24 wrong.
Yeah, that one was really confusing.
I'll post the answer because I wrote it out. I'll send the answer.
Wouldn't it be f of x on the bottom?
Yeah,
You're right. Thank you. Thank you for catching that. You know how I was right. Thank you for catching that. Okay. So to review, derivative of the top, leave the bottom alone, minus derivative of the bottom, leave the top alone, over the bottom squared. Okay. You can play this back in slow motion if you need it. So f prime at 6, you're just going to plug in all the values for 6. 6, 6, 6, 6, 6. Okay. So in this case, I'm not going to rewrite it. Let's just write in the numbers. G prime at 6, looking at on my left, is going to be -6. F of 6 is going to be 1, minus f prime of 6 is going to be -1. G of 6 is going to be 7 over f of 6 squared. F of 6 is 1. -6 plus 7 over 1 is going to be 1. So the reason why I'm assigning these IXLs is because, like, seeing this repeatedly eventually starts to click in your brain that this is not a big deal, and don't freak out over it. But you have to take the derivative first, so then you have parts that you can plug in.
Mister?
Yes, question.
Sorry. You know how people usually go
Super fast homework. Just take the derivative. And for problems like this, we remind ourselves that when I'm adding in a derivative, we do them separately. Each of these are actually a separate problem. The derivative of 28x is just, so f prime, following my label, is just negative 28. And the derivative of negative 41 is 0. Don't write it. If you want, you can write 0 if you want. Just right now, it's just negative 28. So you're going to do the derivatives as fast as you can because you don't want to do homework forever. But that's it. Let's go ahead and take a look at the next problem. Let's just write it. Negative 28. Now, just to say one more thing, if you look at this equation here, is that an equation of a line or a parabola?
Line?
Line. And isn't a line y equals to mx plus b? And my m is negative 28, which is my derivative. That's the change of the line. Okay? So just as a follow-up. So the derivative tells me the slope. It tells me the change at any given point. For a line, negative 41, the change is constant because it's the same change throughout the line. Okay, so the derivative of 20x is, this is a constant multiple. If you want to look at it this way, let's use a g. So 20 stays the same, and the derivative of x is 1. And I'm going to show you this right now. If I say x to the 1 power, okay, x to the 1 power, if I take the derivative of x to the 1 power, the exponent goes where? To the front. And then we always minus 1 from it. I'm going to write it out. X to the 1 minus 1. Oops, turn it. X to the 1 minus 1. And what is 1 minus 1? 0. What's anything to the 0 power?
1.
1. So whenever you see a number and the variable x, it's just going to be the number because the x always goes to 1. And just as another look, hey, if this is the equation of a line, isn't 20 the slope? Isn't 20 the change? So if I wrote 5x, the derivative of 5x is 5. The derivative of 72x is 72. The derivative of, let's say, pi x plus 4, pi. Okay, let's move on. Jump just a little harder. So this problem looks slightly harder. F of x is x squared, 10x squared, plus 21x minus 69. Now, as a FYI, remember this, whenever there's a plus sign, you treat the problem separately. So the derivative of 10x squared, follow the power rule. The 10 goes to the front. 20x 2 minus 1 is a 1 exponent, or don't write it. The derivative of 21x, we just talked about it, that's just 21. Make sure you practice that so this becomes second nature to you. And the derivative of 69, that's 0. Okay, that's it. 20x plus 1. Now, this brings to the case that if you can take the derivative of a regular polynomial, super easy. Even if I write something like f of x is equal to 10x to the 6 minus 4 over 3x to to the, let's say, third plus 2x plus 5. Some dumb thing like that. If it's a polynomial, always super easy. Bring down the exponent, bring down the exponent, bring down the exponent, no exponent. So it'll be 60x, 6 minus 1 is 5. The 3 and the 3's divide out, leave me a 4. x3 minus 1 is 2. That's automatically going to be a 2. And plus 0. Don't write plus 0. Also, make sure the label is correct, that this is the original function, and this is my derivative. So the little mark here refers to f's derivative, f prime. That's our notation. But this is another way of saying f's derivative. Look, it's f's slope. Now, what if you end up with a division problem? And this division problem is very specific. Let's write it as x squared plus 3x plus 2 all over x. Is this a polynomial? It's
Yes.
not.
No.
No, because we're dividing by x. So it turns out this is what we call a rational. And rational is a fancy way of saying division. But maybe this is what you're thinking about. Maybe I could change this into a polynomial. Maybe that's what you were going for. Well, could I divide x's across here? And I'm just going to rewrite it as x squared divided by x. So bear with me. I'm taking my time writing it. Bear with me here. And I think it's going to be helpful. Because remember, when you're dividing, you could separate your divisions into separate fractions. So we're going to have x plus 3 plus 2 over x. But I'm going to rewrite 2 over x. Bear with me here. I'm going to rewrite this as, instead, 2x to the negative 1 power. Bear with me here. That's not bad, right? 2 to the x negative 1. 2x to the negative 1. Now, if I now take the derivative of this problem, what is f prime of x now? The derivative of x is 1. The derivative of 3 is 0. And we can do this derivative really quickly in our head if we just do power rule. Power rule would change the problem to become a negative 2 x to the negative 2 power. We could rewrite this as 1 minus 2 over x squared. Does anyone need help of how I wrote x squared on the denominator? Okay. Now, this is 100%. This is a great problem. Works.
Wait, so the -2, that just means that it was over, it's going to be like denominator, it's going to be a fraction?
Yes.
-2x.
That's all a negative exponent means. It means you don't belong here. Get back on your side of the train tracks, I guess. Get out of here. You don't belong here. You don't belong up here. You gotta get down there.
So when you turn it back into a fraction, it goes back to positive then, basically.
Yes, because now it's like where it's supposed to be. So back from algebra 2, just on the side here, just on the side, right? If I wrote something like 1 over x cubed, this could be written with x on top with a negative exponent. You could even write it something kind of weird. If I wrote x to the negative 2, hey, does this negative 2 really belong here? No, you could write it on top as a positive 2 on top. It just means you don't belong here. Get back over there. Do you guys ever have friends visit Hamilton, and when they check in the front door, they give them a little sticker that says visitor? That's what this is. It's a visitor sticker. If it's a negative sign, you're a visitor, but once you leave, you're okay again. It becomes positive. what if I didn't want to do this by simplifying it? Now, honestly, how hard was this derivative here? Not really, right? Now, you could have done this doing quotient rule. X squared plus 3x plus 2 divided by x. If we did the quotient rule, would it give us the same answer? And you're thinking, of course it is, Mr. Ko. If not, you wouldn't bring up the point. So if I do the quotient rule, it's derivative of the top, 2x plus 3, leave the back alone. Okay, remember, derivative of the top, leave the back alone, minus derivative of the back, leave the top alone, all over the bottom squared. Okay. Let's see if we have any like terms to cancel out. So this will become, let's see, that's 2x minus x is going to be x squared. Whoops, my bad, made a mistake. You have to distribute, so let's rewrite it. 2x cubed plus, oh darn it, that was an arrow. 2x squared plus 3x minus x squared minus 3x minus 2 all over x squared. We can simplify this equals to like terms, x squared minus 2 over x squared. Does this look like my answer up here? Yep. If I give myself a common denominator, this does equal to 1 minus 2 over x squared.
Mr. Cole.
Yes, Nama?
So how do you make the x squared plus gx plus 2, and then the next you made it 2x plus 3 times x, and then minus 1 times that?
Wait, I'm sorry. We're talking about right here?
Yeah, that part. How do you
Okay.
get yeah,
So
the 2x
let me
plus
erase
3?
this wackiness here. So since it's a division problem, if I take a derivative of a division problem, I must use the quotient rule. And the quotient rule goes, as I mentioned before, derivative of the top, leave the back alone, derivative of the back, leave the top alone,
All right, yeah.
all over the bottom squared. That's just the pattern we have to remember and stick to.
Mm-hmm.
No matter how ugly it is, you stick to it.
All right.
And then we have to simplify the problem before we can combine like terms.
Mm-hmm.
And we'll always have like terms. Now, to say this, which one is easier? For sure. If you could simplify the fraction and end up with like a dumb polynomial in the front, do that. And it will save you time. Okay. There are some problems in which you might want to just do long division. And we'll look at those later. Okay. So these problems on IXL today are really just working out you being able to take the derivative of polynomials. Okay. So this one here, example is you could just, no work needed. Just write the f prime of x, make sure you do label it f prime, that's a derivative. That's negative 21x squared minus 4x plus 5. Slow down. But try it yourself. Bring down the exponent and then minus 1. And see if you get the same answer I do.